Hello, my name is Weikert. I'm partner with Tristan Stevens. This is for Programming Assignment 4. Programming Assignment 4 is just a control plane which draws out our network topology. It does this by using routing tables, and the routers forward their tables to their neighboring routers, and then those forwarded onward, etc., until the whole network is mapped out. Something called a Bellman-Ford algorithm is used to keep track of the costs associated between their component and another component, keeping track of the smallest cost. So in the first 3 questions, that will be a part of this video, and then we'll go over the other questions in future videos. So to get started, let me run this for you so you can see it works. And then we see that the routing, we are told to generate a nice print statement for the routing tables. So we can see that router A has a router A to router A a cost of 0. That makes sense. Router A to host 1 has a cost of 1. Router A to router B has a cost of 1. And those were just given to us by the professor. And then router B, likewise, router B to router B 0, etc. And then we were told to update the send routes, update routes functions. So I'm just going to show you these print statements down here that track that until convergence is received. You can see converge routing tables there. So we can see that router A is forwarding its routing table to router B, which just keeps track of the different components it's connected to along with their costs. So we can see that router B received from router A, and then router B forwards it onward. And eventually this keeps going until it converges, and then we can see that host 1 is sending a packet through the network. And then host 1 from interface 0 to RA0, we transmit the packet, RA forwards the packet, and then this is the quickest way through our network. That's because our networks just kind of align. Okay, thank you.
Hi, I'm Tristan Stevens. I'm in charge of Part 2 on Programming Assignment 4. So for Part 2, what we were instructed to do is to modify the forward packet of the router to route according to a routing table. So let's test that quick. So as you can see here, we routed host 1 to router A to router B to host 2. Host 2 received the packet and then sent back a packet. Host 2 goes to router B to router A to host 1, and then host 1 received the packet. So part 2 is working as planned. For part 3, we were instructed to change the routing table to include 2 additional routers and to have host 2 send a message back via a different path than host 1. So to do that, I added 2 additional routers in the simulation Python file and added the additional links between the routers. So let's go ahead and test this. So simulation 3 just got done running, and if we follow the path, we go from host 1 to router A to router C to router D to host 2, and host 2 received the packet. Host 2 then sends another packet from host 2 to router D to router B to router A, then router A to host 1, and then host 1 receives the packet. So that's Programming Assignment 4, Part 2 and 3.